Hey there, physics pals. Paul Lake here with another physics problem solved. This is the channel where I solve the physics homework problems provided to me by my tutoring clients. See the video description below for a way to get in contact with me if you need a private physics tutor. My rates are reasonable and I'm really pretty good at this. And if you find this video helpful, please like, share, and subscribe if you're a physics student. There's lots of other problems that I've got and I'm constantly adding more. So anyway, let's get to today's problem. This is a very beginning of physics problem. So if you're taking an introductory course in physics, this might be the first homework problem you get. It's something like this. The concepts we're going to be using to solve this problem are the concepts of position, displacement, and distance. These have three different meanings. We're going to deal with average velocity and average speed. There's a difference between these two. And then we'll talk about instantaneous velocity a little bit here. And so let's read the problem. It said the position versus time for an object moving along the x-axis is shown in the figure below. So here we have position, and here's where the object is spread out over time. So what is the average velocity between 0 and 2 seconds? What is the average velocity between 2 seconds and 8 seconds? What is the average velocity for the entire 8-second time interval? And D, what is the average speed of the object for the entire 8-second interval? And what is the instantaneous velocity at t equals 6, right there? And one thing, just to be clear, I think that this graph, when it printed or something, it's a little bit off. I'm just going to make things a little bit easier, but by saying this little peak right here, this happens at x. At 2 seconds, our position on the x-axis is going to be exactly 10 meters. And then this doesn't quite reach the bottom here, but I'm just going to pretend like it does. So let's just add that and say here, x is equal to -6 meters. Okay, and this is what's given. Okay, and now what are we trying to find? Let's express it in terms of the variables that we use. And now I use VAV for average velocity. And we want, this is for part A. We want the average velocity for t equals 0 to 2 seconds. And then for part B, we want the average velocity from t equals 2 to, 2 to 8 seconds. And then part C, what is the average velocity for the entire 8 seconds? So B average, and that's from t is equals 0 to 8 seconds. And then for part D, we want the average speed, and I don't know a variable that represents speed, so I just write it out. The average speed for t equals 0 to 8 seconds for the entire time interval. And then for part E, we want the velocity at t equals 6 seconds. And so we'll solve it right here. Now, here's what I suggest. Pause the video right now. Maybe you're working with some friends. Pause the video right now and try to do this yourself. Or if and if you get stuck, just hit play and watch it until you get unstuck, and then pause it again and try to work this problem yourself. And then when you're finished and you understand everything, you watch the video, come back to this problem later, and then do it over and over again until you can do this yourself without having to look at a previously finished solution. Okay, so pause the video now, give it a shot. All right, let's get started. So let's do part A. So we want the average velocity between 0 and 2 seconds. Okay, so, well, what is the equation for the average velocity? And this is hopefully something you've been taught. The average velocity, by definition, is the change in position over the change in time. Delta x over delta t. That's how much did I change my position along the x-axis over that given time interval. All right. Now, anytime you see a delta like this, like delta x, that always means our final x minus our initial x. And in this case, it's time, our final time minus our initial time. So if you just look and pick these values off the graph, you can figure out what the average velocity is. So the final, well, let's take a look at the times first. The final time is 2 seconds. You kind of have to reverse the order, the final goes first. 2 seconds, and then we started at 0 seconds, right? From 0 to 2 seconds. So 2 seconds minus 0 seconds, that's how much time went by, 2 seconds. And then x final, well, at 2 seconds, the final, our position was 10 meters. And then at t initial was 0. Oh, it was minus 0 meters. Okay, so that's pretty easy. 10 minus 0 is 10. 10 meters over 2 minus 0 is 2 seconds. And so 10 divided by 2 is 5. And this means we're going to move, we're going to change our position by 5 meters every second. And this is my answer for part A. And by the way, notice that this right here, 5 meters per second, 5 meters per second, that's the slope of this line from here to here. That's pretty cool. And if you've taken calculus, you might know what that slope is, right? It's a derivative. We'll get to that later. All right, let's do part B. Average velocity between 2 seconds and 8 seconds. Okay, so we're just going to do the same thing. But now my delta x over delta t. Now my x final, well, let's do the time first because that makes it a little bit easier. The final time is 8 seconds. But my initial time, remember it says from 2 to 8 seconds. So 2 is my initial time. See, it's not 0 every time. This time it's 2 seconds. Now at 8 seconds, that's my final time. My position is 0 meters. Minus my initial position, which was going to be 2 seconds. At 2 seconds, oh, it was 10 meters. Okay. And if we do the arithmetic, 0 minus 10, that's negative 10 meters over 8 minus 2. This is always going, the denominator is always going to be positive because we always go forward in time. And so that's going to be 6 seconds. Well, negative 10 divided by 6, 10 goes into 6 goes into 10 once with 4 remainder. 4/6 is 2/3, which is 0.67. So we're going to have 1.67 rounding off to 3 significant figures, meters per second. And this is my answer. Now, what does this negative mean? The negative indicates the direction of the average velocity. This average velocity is in the positive direction. In a positive direction, like, okay, here's my x-axis right here. 0, 2, 4, 6, 8, that's the positive direction. 0, negative 2, negative 4, negative 6, that's the negative direction going down like this. So this just means that the velocity is such that we are changing our position in a downward direction. Okay, this is positive, so we're changing our position in a positive direction. Okay, and this is the slope of the line. This is a slope between here and here. If I was to draw like try to draw a straight line. Let me fix this. So that straight line from here to here, the slope of that line is what this is right here. Okay. Important idea. Now for part C, we want the average velocity again on delta x over delta t for the entire time interval. Now, The time interval ends at 8 seconds. That's my final time. And my initial time, well, it would be 0. And then at 8 seconds, my position is 0 meters. Minus, and my initial position, well, my position on the x-axis when t equals 0 was 0. Oh, 0 minus 0. Well, in most countries, that's 0 over 8 seconds, but 0 divided by 8 is 0. So 0 meters per second, right? Now, what does this mean? This means that over that 8 seconds, I ended up where I started. It's as if I didn't go anywhere. My average velocity is 0 because my delta x was 0. You have to obey this operational definition. An operational definition is a definition based on a procedure. You follow this procedure to get the average velocity. The procedure is delta x over delta t. Delta x over delta t. And you follow that. I mean, this just means, yeah, overall you didn't go anywhere in that time interval. Now part D, we want the average speed. So I'll just put average speed. And this has a different operational definition than average velocity. What you have to do here is figure out the distance traveled, regardless of direction. Distance is always positive. It's just the length of the total path that this object walked up and up. Remember also that the motion of this object is just up and down here. It's not like something is moving like this and then down and then like, no, it's going like this, up and back and forth. One-dimensional motion along the x-axis. We just take this back and forth motion and we spread it out over time to create a position versus time graph. So getting back to average speed, okay, well, this is going to be 8 seconds, right, for the whole time interval. But we have to figure out what distance was traveled. So let's do it like this. From 0 to 2 seconds, I went 10 meters up, like that. So 10 meters. And then from 2 to 4 seconds, I went from, here, and then I went down 2, 4, 5. I went down 5 meters, like that. So plus 5 meters. And notice, this is not negative 5 meters. If you were talking about a displacement, a change in position, it would be negative 5 meters. But we're talking about distance. So how far did you go? Regardless of direction. So this is 1, 2, 3, 4, 5 meters. And then from here to here, how many meters did I go? Right? I went down all the way down here. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I went from here to here is 11 meters, right? Because this is 5 and this is negative 6. To go from 5 to negative 6, I have to travel 11 meters. And then I come back up. I go from negative 6 meters back up to 0. Well, that's 1, 2, 3, 4, 5, 6. 6 meters. So I just added up all the distances that I traveled. And when I do that, see, this is 10 plus 5 is 15 plus 11 is 26. 26 plus 6 is 32. So that's 32 meters divided by 8 seconds. And this is 4 meters per second. Isn't that interesting? You see, my average velocity, based on how I define velocity, is 0, because I ended up back where I started. But this is speed right here. This is on average how much ground was I covering, even if I ended up back where I started. Now, in a lot of contexts, average speed makes more sense than average velocity. And I like to use the Indianapolis 500, that car race. The winning car has an average velocity of 0 because the starting line is the finish line. So when it wins the race, it's where it started, or pretty close anyway. So but what it traveled about 500 miles in, I don't know, like 2.5, 3 hours. So it's probably averaged about a little under 200 miles per hour. That's its average speed. And in that context, average speed makes more sense than talking about average velocity. But there are a lot of situations where average velocity is what you really care about. So it depends on what you're doing. When you use average speed and when you use average velocity. All right, let's do the last one. And that is we want V instantaneous. Now, the instantaneous speed is the slope of the position versus time graph. I mean, look, these are all slopes, right? The A, B, and C, these are all slopes. Like the slope from here to here, 0 slope. The slope from here to here, negative 1.67. The slope from here to here is 5, right? But right here, the instantaneous velocity is the slope right there. What is the slope of the line right here? Now, luckily, this is not this is a straight line through here. So if I can figure out what the slope of that straight line is, I'll have how fast we're going at that instant at 6 seconds. So I will go delta x over delta t. Now this has the limit is delta t goes to 0. You know, the official definition of instantaneous velocity is this limit thing. And I'm gonna make another video about how to take derivatives and what they mean and so on. But for this problem, what you can do is just take the slope of the line that this landed on. So let's do that. Now, what I'm going to do is I'm going to start here and I'm going to end here. So this ends at 7 seconds, but it started at 5 seconds. And at 7 seconds, the velocity is negative 6 meters. I'm sorry, not the velocity, the position is negative 6 meters. And at negative 5 seconds, I'm sorry, at 5 seconds, positive 5 seconds, my position was 5 meters. Okay. And so what do we got here? We've got negative 6 minus 5 meters. That's negative 11 meters. 7 seconds minus 5 seconds is 2 seconds. And so 11 divided by 2, right, that's 5.5 meters per second, but in the negative direction. So that means that at that instant, as we're going from here to here, we're chugging along. This whole time, we're chugging along at negative 5.5 meters per second from here down to here. Now we change velocities here, and then we were going 0 velocity here, but from here to here, we're going negative 5.5 meters per second. And so when you pass through 6 seconds, this is how fast you're going at that instant in time at t equals 6 seconds. And if you find this helpful, if you like this video, please like it. It helps me so much and helps other students find this kind of stuff. And subscribe if you're a physics student or a physics teacher. If you're a physics teacher, use this video in class. I'd be honored, actually. And yeah, check out my other videos. Go leave a comment. And until I see you again, thank you for watching. May the net force be with you always. That is all.